section 1.4, which was this idea on distributive property, and discuss what's called factoring. It's everyone's favorite F word in algebra, factoring, but it's probably one of the pillars, again, that we talked about in algebra. Linear equations, exponents. This idea of factoring is one of them that repeat all the time in Algebra 1. And if we remember from the last unit or chapter, this idea of distributive property, it's an important property that allows us to multiply across through terms that are being added together. So for example, if you had something like 4 parentheses 2x plus 5, you could distribute the 4 that's on the outside to the 2 terms that exist inside the parentheses, and that would give us 4 times 2x is 8x, plus 4 times 5 is 20, and this is our simplified solution, meaning that there's no parentheses left, and then all the like terms are gathered together. Simple distributive property idea. One quick note on distributive property. If we have something like 2 parentheses x plus 3 minus 3 2x minus 4, again we can distribute the values that sit inside of both sets of parentheses here. We're going to take the 2, distribute to the 2 terms on the inside of this. That would give us 2x plus 6. And then again, an important idea here is this minus 3 quantity 2x minus 4, that negative sign really is attached to the 3. Remember, this is really the same thing as the additive inverse idea. It's plus negative 3, then parentheses 2x minus 4. So remember to keep that negative sign with the 3 so that when we distribute, you have negative 3 times 2x is negative 6x, and negative 3 times negative 4 is positive 12. Alright, that's a classic or a common mistake in algebra in which you distribute and you forgot to distribute the negative sign along with that coefficient. Remember, the number that sits in front is a coefficient that sits out there, or the constant term. The next step to do is we've cleared the parentheses, so to simplify further, we gather like terms. There's a 2x and a negative 6x. So 2x minus 6x is negative 4x. And then we have a 6 plus 12 is plus 18. And there's our simplified expression after we distribute and gather like terms. So when we say this idea of factoring, and then get used to that phrase factoring, you see that very, very often in Algebra 1, what we're really doing is the undo or the backwards operation of distributing values on the or distributor property. So for example, you see this idea that will say factor, and then they'll give you something like 3x plus 15, which means this to us when we are asked to factor. The first thing you always check for is, are there like terms that we can gather together? The answer is usually going to be no. They'd have simplified it for you already. And what they want you to do is this. When you factor, you think of a number in front, blank, paren, paren, and then there's a plus sign here. Oops, let me move this over so we can see it. Again, so we have some number that must have been in front, parentheses, and then there's a plus sign because it's a plus problem is the easiest way to handle that right now. Then you think to yourself, well, what must the number be that sits in front? So what you're saying to yourself is really, you look at the coefficients or the terms, the whole number values, if you will, that are in the given expression. So 3 and 15 is what I'm focusing on. So between 3 and 15, what's the greatest common factor between 3 and 15? Your GCF. So factoring in this form is all about GCF, your greatest common factor. So the greatest common factor between 3 and 15 is basically 3. Okay? So if you factor that out, well, what must have been left over so that if I multiply 3 times what gives me 3x? Well, it's got to be plain old x, right? Then you're saying to yourself for this last term here, well, 3 times what would give me 15? It's 5. And this is your factored form. Okay, so it's like going backwards. In fact, it's exactly what it is. It's going backwards. So the way you can check if this is the correct answer, well, if you distribute, you get 3x plus 15, which was what we got originally as the original problem. So yes, that is the correct factored down form of the expression. And if you have a subtraction problem, you handle it in a very similar fashion. We would say this equals, well, some number, parentheses, I'm going to put a subtraction sign here since it was a negative sign in between, or subtraction problem. Then once again, we're going to focus on these two guys right there, the 4 and the 20. What's the greatest common factor between 4 and 20? Well, it must be 4. Then you say to yourself, well, I got this 4x term here in this first spot. What must I multiply 4 by to get 4x? Well, namely x. And then what must I multiply 20 by? Multiply 4 by to get 20. Well, it's got to be 5. And there is our completely factored down form. That is our solution. And to check it quickly, well, if I distribute, 4x minus 20 is what I get back. All right. So that's basically factoring out expressions, and you look for common terms. It does get a little bit more involved. So we're going to look at one of those today. Well, what happens if we have something like 36x plus 24. Same thing, we're going to equals some number, parentheses, parentheses, we put a plus sign in between them. All right, we're saying to ourselves, well, what is the greatest common factor between 36 and 24? Well, it looks like we can go 3s would work, even higher. Looks like 12 would be the greatest common factor between the two, so we'll factor out a 12. Then what times 12 gives us 36 x's? It's not just plain old x anymore, like the two previous examples. There's also another value in front. It's got to be, well, 3 x's, because if I want 12 times 3x, that would give me 36x, all right? And then what times 12 gives us 24? Well, that would be 2. So now this is the completely factored solution. And again, you can quickly check mentally by distributing. You get 36x plus 24, all right? A slightly more challenging problem comes in when we're asked to factor something that has more than just a whole number involved as a common factor. Okay, so we've seen problems like this, and this is not a factoring problem, but we'll say 2x on the outside, 3x plus 5 on the inside. This is a distribute problem. So again, once again, from last section, we'll distribute. That would give us, well, 2x times 3x gives us 6x squared. Or if you do x times x, you get x squared. Plus 2x times 5, that gives us 10x. You can't combine these two terms together because they're not like terms, so we've simplified it as far as we can. Now, the factoring problem would be something like this, in which we have (5x squared plus 10x). So once again, if we're factoring, our job is to figure out, well, there's something in front, parentheses, parentheses, there's a plus sign in between. Our job is to figure out the greatest common factor between these two things here. Now, in this case, since there's x's involved in both the two terms that we're starting off with, notice the ones previous to this when we're asked to factor, there was only x's in the first term of each of them, not in all three terms. Rather both terms. That means we're going to be factoring out x's as well. So I do this in order for me to factor this. I start with the whole numbers first. So between 5 and 10. All right. So you start there. So between 5 and 10, the greatest common factor clearly is going to be 5. Okay. Then the next thing I do is, well, I say to myself, in the two terms in my original problem, are there x's in any of them? Just any kind of x's. It doesn't have to be square, just x's present. Then the answer is yes. There's an x squared and an x. So between x squared and x, I say to myself, well, what's the lowest power between the two? That's how you decide how much to pull out. The lowest power between the two is, well, it's got to be x, because, you know, it's lower than 2. Then that's my greatest common factor. I will be factoring out of 5x. So in my head, then I say to myself, well, 5x times what would give me 5x squared? Well, times plain old x would do that. All right? And then I say to myself again, 5x times what, that's the part that goes here, the what, gives us 10x. Well, if I want 5x to become 10x, I got to multiply by 2. So this is my complete problem factor down. Okay, and then we can check it quickly by, well, if I distribute, well, 5x times x is 5x squared, plus 5x times 2 is 10x, and there is my original problem, in which I have completely factored down. I got the original problem back when I distribute. They kind of undo each other. All right. So the matter of factoring out common expressions like we do, that's in fact what we're doing here. It's just a matter of practicing different varieties of this, and it's not in your book, so it's just kind of a spin-off, but it's a good way to introduce how to undo distribution properties. Until next time.